Hi, Wanida.
Hi.
I've got something to ask you.
What?
Have you been focusing on ceramic class yesterday?
Oh, you are not focused in class, right?
Yes.
Okay, let me explain back to you about gravimetric analysis. Before that, I will tell you about chloride meter first.
The amount of chloride in water and fluid is important because it can affect taste, safety, and overall of the quality. For example, if too much chloride in water, it can cause an unpleasant salty taste and may indicate contamination. Because chloride cannot be seen directly, we need a reliable analytical method to measure it accurately. One of the most accurate methods used to determine chloride is gravimetric analysis. Gravimetric analysis is a quantitative analytical technique that is based on the measurement of mass. In this method, the substance we analyze, and also known as the analyte, is converted into a pure and insoluble compound. This compound is separated, dried, and weighed carefully. The accuracy of this method comes from precise weighing rather than instrument calibration. There are several types of gravimetric analysis, which is a precipitate gravimetric, volatilization gravimetric, electrogravimetric, and thermogravimetric. For the selected topic that is chloride, the most suitable method is precipitation gravimetric. Precipitation gravimetry is a quantitative analytical method in which the analyte is chemically converted into an insoluble precipitate. The precipitate is then filtered, dried, and weighed to determine the amount of analyte that present in the sample. For volatilization gravimetry, it involves converting the analyte into volatile substance through heating. The change in mass before and after volatilization is measured to determine the quantity of the analyte. 9. Electrogravimetry is a gravimetric technique in which the analyte is deposited onto an electrode by applying an electric current. The mass difference of the electrode before and after deposition is used to calculate the analyte concentration. Lastly, thermogravimetry is a gravimetric technique that measures the change in mass of a substance as a function of temperature or time under controlled heating conditions. It is commonly used to study thermal decomposition, composition, and stability of material. Why gravimetric analysis is accurate? Gravimetric analysis is accurate because the analyte is chemically converted into a stable, insoluble precipitate with a fixed stoichiometry. The precipitate is filtered, washed, dried, and accurately weighed. From the mass of this compound, we can calculate the amount of the original substance that present in the sample. Since the method is based on precise mass measurement, the amount of the original substance in the sample can be determined with high accuracy. I also do not fully understand everything that has been taught in class, especially about application of gravimetric analysis. Did you know about the application of the gravimetric analysis?
I've been jotting down everything about it. So, first I will tell you there are several types of application in our daily life based on the gravimetric analysis. First, I will tell you about the purity determination, mixture composition, environmental testing, and industrial quality control.
Our main focus is about the application of gravimetric analysis in determination of chloride in water. In this method, chloride ions present in the water sample are chemically converted into an insoluble compound, which is silver chloride, by the addition of an excess amount of silver nitrate solution. Upon the addition of silver nitrate, chloride ions react with silver ions to produce a white and curdy precipitate of silver chloride. What is the use of gravimetric analysis? Gravimetric analysis is used to measure the concentration of chloride ions in drinking water by converting them into an insoluble precipitate. This helps evaluate water quality and ensures that chloride levels comply with drinking water standards. Why determination of chloride is important? Determining chloride level is essential for evaluating drinking water quality, as elevated chloride concentration can cause a salty taste, enhance the corrosiveness of water, and indicate possible contamination from sources such as seawater intrusions, industrial effluents, or sewage.
That's all about the application of gravimetric analysis.
Okay, what's about the procedure?
About the procedure, what if we ask our mentor, Zainul Zafran? Let's go.
Okay.
Hi, Zain.
Hi Anna, hi Wanita.
We've got some questions to ask you about why. We want to ask you about the procedure of gravimetric analysis.
Oh, I see. So, for your information, before we proceed to the procedure, we must know about the material and apparatus, like this.
Oh, like that.
Yes. But, if you want to run the procedure, you must know about the precaution. There are 4 precautions. First, we have the ensuring purity of precipitate and avoiding loss of sample to prevent the chemical hazard. And last is controlling environment variables such as like light or moisture. But for the calculation, I don't know how to do it. If you want to know, you can ask to Afrina.
Okay, thank you.
Go.
Welcome. Hello. Hi, Afrina.
Hi.
Please teach us about the calculation.
Oh, yeah. Let me show you. Okay, now let me show you how can we calculate the chloride ion from our silver chloride precipitation. So the first step, we need to write the equation. This is the primary equation, how silver chloride come from. It comes from the silver ion and chloride ion. And this is a complete balance equation, how our silver chloride precipitation come from. We use the silver nitrate on our sodium chloride, which is this sodium chloride we can find from our from chlorine salt of our sample. So this is a product which is silver chloride, our precipitation. So after we write the equation, the second step is we need to find the gravimetric factor of GI. So for example, our sample, we got the mass 0.241 gram. This 0.241 gram comes from 100 ml of volume. So this is the formula of gravimetric factors. Our analyte is chloride ion and our precipitate is silver chloride. We need to times this with the mole of precipitate and mole of analyte. So the formula weight of our analyte is 35.5 gram per mole and the formula weight of our precipitate is 143.5 gram per mole. We need to times with this mole of precipitate and analyte, which is 1/1. Why 1/1? This 1/1 comes from this primary equation, which is 1 Cn, 1 chloride ion will become 1 silver chloride. So that's why 1/1. So we got 0.2474. This is our gravimetric factor value. The third step is we need to find the mass of our chloride ion. So this is the formula. We use our GI value times with our weight of silver chloride. So our GI value 0.2474 times with 0.241 gram, which is our weight of silver chloride, and we got 0.05. We get 0.05962 gram, which is our mass of chloride ion. So after we got the mass of chloride ion, the last step is we can find the concentration of chloride ion. So this is the formula of how can we find concentration. We use the mass of our chloride ion and we use over volume of our sample, which is 100 ml. So 0.05962 gram over 100 ml, we got 5.962 times 10⁻⁴ gram per milliliter. But we need to perform our concentration in milligram per liter. So we need to convert this unit now. 1 milligram equals to 1 times 10⁻³ gram and 1 liter equals to 2000 milliliter. So how can we convert the unit? From the value we got, 5.962 times 10⁻⁴ gram over 1 milliliter, which is because gram per milliliter, times with 1 milligram over 1 times 10⁻³ gram, because 1 milligram equals to 1 times 10 times -3, and times with 1000 milliliter over 1 liter, because 1 liter equals to 1000 milliliter. So at the end we got 596.2 milligram over liter. So this is our concentration of chloride ion. Okay, that's all for me. That's all from me. How can we calculate the concentration? Now, I want to talk about the acceptable limits of chlorine in our drinking water. From the information that I got, US EPA state the maximum value is 4 ppm. Also, from World Health Organization or WHO, they state that health-based guideline of chlorine in our drinking water is 5 ppm. So, in average, they conclude the ideal residual level of chlorine is between 0.2 to 0.5 ppm. So, if your drinking water is outside the optimal range set by the responsible party, then the drinking water is not safe to consume. The example of the amount of chlorine in the previous calculation is just an example to show how can we calculate to find the chlorine value in our drinking water.
So, we can conclude the gravimetric determination of chloride using silver chloride precipitation is a simple yet highly accurate analytical method.
This technique is based on direct relationship between mass of precipitate and amount of chloride present.
Due to its reliability and precision.
This method is widely used in water analysis and food quality control.
That's all from us. Thank you.